All right, so today we're going to find the cross product of vectors using the algebraic definition. So here we have to find two different cross products. We're going to do v cross w and then w cross v, where we're given our vectors up top here. So we'll start with A. Essentially, the algebraic definition is saying that we're going to take the determinant using the coefficients of these vectors in the order that they're given. So starting with v and then w, and then for b it would be starting with w, then with v, and using those with our vectors as the top row. So that would be I, j, and k. Okay, so I'm going to actually set that up for both of our problems, and we'll kind of see how they compare and then fill in our coefficients. So for v cross w, it's going to be 3, 2, and -1, and then -4, -3, and 5. And again, those correlate to each of our coefficients here. Now for our problem B, kind of setting these up just as we go in order to show you how they might be different. Those would be swapped because w comes first in this cross product, and that does matter in this case. These coefficients for w would need to come first, as in, you know, the first row that you write after using I, j, and k as the vectors at the top. So at this point, we're just going to use the definition of a determinant to find whatever these are. Now, I know there's multiple ways to find the determinant. I know some people do it the way of using I and then finding the smaller determinant of the 2 by 2 that is separate from that. That's what I'm going to do, but I'm going to kind of do it shorthand. And I know as well, some people kind of use that, the diagonal method, where you'd copy these two columns and then take each of your diagonals as you go and then subtract them in the middle. So you have options here on how to do that, but generally it just stays the same as it does in any kind of matrix math. So that's what I'm going to do now. So when I do my determinants, I'm pretty much going to say, well, it's going to be something times I, subtract that middle part just by definition, something times j, and then add, or whatever, you know, the coefficient ends up being, each of these vectors. Okay, so doing it kind of the shorthand way would be, let me find a different color. We're getting rid of whatever has the row and the column of I and taking the determinant of that. So I'm going to do 2 times 5, which gives me 10. And then my next value would be 3. And again, we subtract the numbers in between there because of the definition of the determinant. Same thing for j. So get rid of everything around that, and then we're going to end up with 15. And then it looks like -4. All right, last one. What do we have here? -9, and then minus -8. So +8 is what that ends up becoming. So our final answer here, we just kind of simplify everything. Looks like 7i minus 11j minus k. All right, so that would be our cross product here for v cross w. If we want to put this together, we'll do a nice answer here. That's v cross w. So to find our opposite, right, the other, you know, question B that we're doing here, looks very similar, right? Really, it just ends up being slightly different. It might be interesting to note the pattern that we see here if we end up calculating this as well next to it. Might be interesting. So let's go ahead and do the same thing. Something I minus something j plus something k. Right, and then figure out what our numbers are going to be. So ends up working out the same, except you'll notice pretty much my numbers end up being flip-flopped, right? Because what I've done is I've flip-flopped w and v and where they lie in my calculating the determinant. So it ends up being 3 minus 10, 4 minus 15, and then -8 minus -9, so +9. So what we end up with is -7i minus 11j, which turns into a positive, and then plus the vector k. Okay, so then our last one ends up being w cross v right there. Again, very similar answers, but essentially just opposites of one another. So that would be how we find the cross product using the algebraic definition, setting up the determinant using the vectors I, j, and k, and finding the determinant using that. All right, thank you for listening.